Hi dear, today we'll see the chemistry activity 1.7. Okay, so we are going to learn so many things in this single activity. So okay, first what we have to do, take a plastic mug, drill 2 holes in its base and fit rubber stopper in these holes. Okay, insert carbon electrode in this rubber stopper. So what we have to take a plastic mug. Okay, so we have to put 2 holes here. Okay, and then fix it with the rubber cock. Okay, in that we have to insert two electrodes, that is carbon electrodes. Here we have taken this graphite. Okay, so carbon electrodes has to be fixed. Why we have put the cork means it should not leak. Water should not be leaked from this. Okay, so we have put the rubber cork here and we have inserted the rod here. Okay, electrode with this graphite rod. Okay, next, connect these electrode to a 6-volt battery. So we are going to connect these rods to a graphite to a battery. Okay, fill the mug with water such that electrodes are immersed and a few drops of dilute sulfuric acid to the water. So we are going to fill the mug with the water. This electrode should be immersed in the water. Okay, the electrode should be this electrode should be immersed in the water. So up to this we are going to fill the water. Okay, to this we are going to add a few drop of dilute sulfuric acid to the water. Okay, why we have to add sulfuric acid to this water means, so we are going to do this activity. What activity? This is electrolysis of water. Okay, so that is decomposition of water is going to take place using the electric current. Okay, we are going to do that activity only. So what is the product of this decomposition of water molecules? Your hydrogen gas and oxygen gas, right? So this water is decomposed into hydrogen gas and oxygen. Okay, so why we have to put a drop of dilute sulfuric acid means, this current, no, we are passing the electric current, no, it has to conduct it. This water will not conduct electricity because there is no ionized charges in that, because here the water molecule, you know that H2O. So this oxygen is combined with this hydrogen like this, it will form a covalent bonds. Okay, so it will be like that only. So there is no ion free charges present in this water, so the electric current will not pass through that. Okay, to pass the some of the minerals or salts will be present, only few things will be there, so slightly it will conduct. Electricity will pass through the water, slightly it pass. To increase the conductivity we are going to put few drops of dilute sulfuric acid. Okay, what happens when dilute sulfuric acid, when you put it in the water, it sulfuric acid forms H2SO4. So it will dissociate into H plus ions and SO4 minus ions. Okay, H plus ions and SO4 minus. So it will dissociate and you will get the charges. Free ions will be there. Now electricity it can pass through this. Electricity can pass through this. Okay. For that purpose, to increase the conductivity, we are putting the few drops of dilute sulfuric acid. Okay. Next, what is the next step means? We need, so you know that the products are hydrogen and oxygen. So we need to collect that gas. It is evolved in the form of gas, right? So take 2 test tubes filled with water and invert them over the 2 carbon electrodes. Okay, take a test tube like this, fill with water. Make sure that it will not make sure that it is inserted properly over these rods. Okay, this is one of the tube and this is another tube, so you have to invert them and put it over the electrodes. Okay, carbon electrodes. Okay, next, switch so connect so it is connected to the battery. So if we are connected to a uh, so connect to the battery. So once the switch on the current, if it is a button system, you switch on the current and leave the apparatus undisturbed for some time. Okay, what will you observe? So after some time you can see a bubbles over the rods. You can see some bubbles are coming from the rod. Bubbles are coming from the rod. Okay, bubbles are coming from the rod, and this bubbles will replace this water. Okay, this bubbles already water is, because we have inverted the test tube contain water, right? So water, this test tube contains full of water. Now this bubbles gas will replace the water molecules. Okay, so what is the reaction taking place in this? So your observation is, first observation is, some gases evolved in both the electrodes. So you can see the bubbles formed on the electrodes. Okay. Next observation, gas on one electrode was more than that of the other electrode. So you can clearly see that once the bubble started coming, you can see. So here more gas is there. See, this is more gas. And here it is less gas. All the water molecules will be displaced with this gas. Okay, so one test tube contains more gas when compared to the other. Why? Because you know that when electric current is passed over the water, it decomposes into hydrogen gas and oxygen gas. Okay, if you balance this equation, how many oxygens are here? 2 oxygen. To make it to 2, we have put 2 here, so the hydrogen become 4. So we'll balance this by putting 2 here. So and here the hydrogen will also become 4. Okay, so if you look at this equation, 2 molecules of water decomposes to form 2 molecules of hydrogen gas and 1 molecule of oxygen gas. Okay, that's why we are getting, so here the 2 molecules decomposes to 2 times of the hydrogen and only 1 part of the oxygen gas. That's why here, that means what? 2 parts of the hydrogen. So more gas is collected, means this shows that this is hydrogen gas, and this is your oxygen. Clear on this? Okay, because 2 molecules of water dissociates to give 2 molecules of hydrogen and 1 molecule of oxygen. So 2 molecules of water decomposes to form 2 hydrogen molecule and 1 oxygen molecule. So the volume of the gas collected in one of the test tube is more, which shows that it is which is more, hydrogen is more. Okay, and the other shows that the presence of oxygen gas. Okay, so your first observation is some gases are evolved. What are those gases? Hydrogen gas and oxygen gas. And what is the second observation? Gas on one electrode was more than that of the other electrode. Why? Because this 2 water molecule decomposes to form 2 hydrogen molecules and only 1 oxygen molecule. Right? So the gas collected more, volume of the gas collected in one of the test tube more, which shows that it is a hydrogen gas. Which one? Other one is less, no, that is the oxygen gas. Okay. Next, how do you know? You can also find out which one is hydrogen gas, which one is oxygen gas by the amount of volume of the gas present in the test tube, and also you can confirm that which gas will be collected in which test tube, and which gas will be collected in which test tube. How do you know that? Means because you know that it is hydrogen gas is H plus, right? So definitely it will reacts with the cathode side only. Okay, when that rod connected to the cathode side, you will get the hydrogen gas, because this is H plus and the cathode is connected to negative side, so it will attract each other, so it will react. So the test tube connected to the cathode side, you will get the hydrogen gas. the test tube connected to the anode side. You know this is O minus. Okay, O minus will attract to the positive side only. So the test tube connected to the anode side, you will get a collection of oxygen gas. Okay. So hydrogen gas is collected in the test tube, which is connected to the cathode. Cathode is your negative charge. Okay. And oxygen gas is collected in the test tube, which is connected to the anode. So O minus means anode. Okay. Next, by chemical equation, you know that hydrogen gas is evolved and oxygen gas is evolved. How do you know that? How will you test that whether it is a hydrogen gas or oxygen gas? Okay, so we can test the presence of hydrogen gas also. Okay, so test for hydrogen gas. So how will you test this hydrogen gas? Means you have collected this gas in the test tubes, right? So slowly you have to take this carefully, and then if you bring this mouth of the test tube near a burning candle. So for example, this is your candle. Okay, if you bring the test tube nearer to this, which contain hydrogen gas is collected, no? If you bring this nearer to this, you will get the squeaky pop sound. Okay, what is squeaky pop sound? Okay, when the gas is brought nearer to the burning candle, we can hear the squeaky pop sound, which shows the presence of hydrogen gas. Okay, actually what is happening then means combustion reaction is happening there. That is, hydrogen in the presence of oxygen, that is, reacts with oxygen to form water molecule. Okay, hydrogen gas when react with oxygen to form a water molecule. Why that pop sound has come? You know that? Because hydrogen gas is highly inflammable. Okay, highly inflammable. When it comes nearer to the fire, it suddenly bursts, right? That is actually a explosion, mini explosion. If you hear that squeaky pop sound, no, that is actually a mini explosion, because it is highly inflammable. When it brought nearer to the fire, it explodes. Okay, the hydrogen gas is highly inflammable. The pop sound is actually a mini explosion. Okay, next, how will you test the presence of oxygen? So if you hear the squeaky pop sound, then it shows that it is the hydrogen gas. Hydrogen gas is confirmed. Next, test for oxygen gas. The same thing. So if you, this is your candle, if you bring the test tube containing oxygen, this is your oxygen, this is your here, this is your hydrogen. Okay, when you bring this test tube nearer to the burning candle, it relights it, because you are supplying more oxygen, so it will be burning like this. The candle will be like this. Okay, when the gas is brought near the burning candle, it relights the glowing candle. Okay, which shows the presence of oxygen gas. Okay, before that it was glowing like this. When you brought this test tube nearer to this candle, it will glow like this. Okay, it will glow like this. Why? Because of the higher concentration of oxygen. You are supplying more oxygen, so it started glowing. Okay, vigorously. Okay, why? Because in the atmosphere, how many percentage of oxygen is this? Only 21% of oxygen is roughly present in the atmosphere. That's why the candle is glowing like this. Okay, only 21% of oxygen is present here. When you brought the concentrated only oxygen nearer to this, it get the concentration of oxygen is more, so it's glowing. Okay, it relights the glowing candle. Clear on this? So this activity 1.7 is the decomposition of one more observation is there. Here it is the electrolytic decomposition. Conclusion is electrolytic decomposition. Because water is decomposed into hydrogen gas and oxygen gas, the presence of electric current, so it is called the electrolytic decomposition. Clear on this? Thank you.